Today we're going to talk about writing piecewise functions given a graph. So we're going to be given the picture of the function, and then we're going to come up with the equation for the graph, including the domain as part of that graph. So if we look at our first picture here, it's actually a picture that we have seen before. And what we're going to have to do is we're going to start by identifying the equations of each of these lines. So in fact they are line segments here. It says, can you identify the equations of the lines that contain each segment? So the first one here is blue, the far left. And when we look at this, we want to identify two parts. We want to identify the slope, which we abbreviate as m. And we also want to identify the y-intercept, which we abbreviate with b. So we're going to put these lines in slope-intercept form. So when we look at the blue segment, what's our slope? Rise, one, run, one. Rise over run, rise over run. 1/1. And we're going uphill, so it's a positive slope. But what we can't identify immediately from the graph is we can't identify the y-intercept. But if we can figure out what the slope is, we can continue that pattern of up one to the right one, up one to the right one, up one to the right one. And I just put a little tiny mark there. But if we were to continue our segment into a line, where would it cross the y-axis? 1, 2, 3, 4, 5, 6, 7. So for our left segment, our blue segment, what we have, if we put this in slope-intercept form, is we have 1x plus 7. You don't necessarily have to write the 1. There's nothing wrong with writing the 1. You can just write x plus 7. When we look at the middle equation here, our middle equation is the red equation. And we have a horizontal line. What's the slope? Horizontal line segment, sorry, but what's the slope of a horizontal line? Tiffany? It does have one, but sometimes it's misleading, or you think of it as not having one because the slope of a horizontal line is 0. Our y-intercept that we can see here is 1, 2. Where does the line cross the y-axis? And technically what you could write is we could write 0x plus 2 for our equation. But if you think back to all the problems that we've worked with this week, have we ever seen 0x plus 2? We've just seen the value of 2. So we're going to fill in 2 for our middle equation, which leaves our green equation. And again, we want to identify the slope, and we want to identify the y-intercept to fill in here. So as we take a look at our slope, anybody see what it is? Matthew? So he says 4/2. We actually down 4, to the right 2, down 4, hopefully to the right 2. Can we simplify that a little bit? Down for the right 2, Jordan, is same thing as down 2 to the right 1. Down 2 to the right 1. Now, we went down. What do we have to write in our equation since we're going downward? Anybody? -2. It's -2/1 if you prefer, because it's rise over run is our technical definition of slope. Now, the y-intercept is a little bit more tricky here. But what we can do here, once we know that pattern, down to the right one is the same thing as up to the left one. And I'm going to put a little mark there. We want to find the y-intercept. Up to the left one, right there at the edge of the graph, and we haven't found the y-intercept yet. Well, we're going to have to go up to and to the left one here, and we're going to have to estimate a little bit. Where are we on the graph at this point? Good. We're at 12, so when we go up to and to the left one here, what is that value, which is going to be our y-intercept? 14. So you've got to keep track of things if it doesn't fit on our graph over here. Use the slope to help you get there. So our green equation is going to be negative 2x plus 14. Well, there's part of this, because we just found the equations that contain these segments. Now we want to look at the same graph, but we want to identify the domain of this. And remember, when we look at domain, we're looking farthest to the left and farthest to the right. We have segments there, so we can't. We have a starting point and a stopping point. So when we look at our blue segment, farthest to the left is negative 6. Are we going to have less than or equal to at negative 6? Equal to. Why are we having equal to? Jordan? Fully shaded circle, right there. Fully shaded dot. Then the farthest to the right point on our blue segment is 1 to negative 3. Will this be less than, or will it be less than or equal to? Tiffany? Open circle is just less than. We're going to do the same process for the red. Looking farthest to the left. 1 to negative 3. Negative 3 is a filled in circle. So we're going to have an equal to. And the question is, over here on our right side, are we going to have equal to at the 4? But as we look at that, we see that that is not a filled in circle, so it's going to be less than. And then let's try the green. Farthest to the left, 1, 2, 3, 4. At 4, we have a filled in circle. So this is going to be 4 is less than or equal to. Farthest to the right of our green segment is 8. 8 is not filled in, so it's going to be less than. Sometimes I say something in the middle, something underneath. Nothing in the middle, nothing underneath. So there's nothing in the middle of this green circle, so there's nothing underneath x less than 8. So once we identify the equations of our segments, once we identify our domain, then we can put the entire function together. And what we do is it says we write down our equations. Well, our first equation was x plus 7. And then you can write if, or you can put a comma. It doesn't make any difference. Then our domain that we just found was negative 6 is less than or equal to x is less than negative 3. There's our first piece. Then we did the red. So we go back to the very top of our paper there, and we see that the red is 2. Our equation for the red is 2. And then we can put a comma. I oftentimes write if. And then where's our domain? -3 less than or equal to x less than 4. And then we need to do our green segment. We go back and we look at our equation of our green segment, which is -2x plus 14. Comma. And then we fill in our domain that we found in part 2. Which is 4 is less than or equal to x is less than 8. So let's try one more. Again, the steps are what we just did. We are going to figure out the equation of the left portion of our piecewise function and its corresponding domain. We're going to figure out the equation of the right-hand portion of our graph, and we're going to figure out its domain. If we look back in the directions here, it says answer the following questions in order to write the function for the piecewise graph to the right. Notice that both parts of the graph are raised, and you already have those arrows drawn in there for you. But now, let's find the equation of the left portion. So that means we need to find the slope and the y-intercept of our slope of our left-hand portion here. It looks like we went up 2 over 1. Up 2 over 1, up 2 over 1. Rise over run. But we also need to identify where does the graph cross the y-axis. And I know we have a ray, so we have a starting point. We don't have an ending point. But if we continue that pattern, we would go up 2 over 1. So what's our y-intercept of that left-hand ray? And hopefully you see it's actually 1, 2, 3. So when we fill in our equation, we've got 2x plus 3. Now, since we're talking about the left portion of the graph, let's also look at our domain here. And remember, we're going to start here at -1. And then our graph is always to the left of that. And it's going to continue on forever. So the way that we can indicate that domain with an inequality is we can say that x is less than -1. The only other question is, are we going to have an equal to in that problem? And what we see is it's an open circle. So no, we're not going to have an equal in that. In our right-hand equation, we need to identify the slope. So if we take a quick look here, we went down 1 to the right 1, 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 down 1 to the right 1. It looks like our slope is -1 over 1. And it's negative because we went down 1. Our y-intercept is already marked with our red point. We can actually see it on here, and it's 1, 2, 3. So when we write our equation, -1x plus 3, you don't necessarily need to write the 1. But where does that graph start? We have a starting point. And it starts up here at negative 1. And then we're going to continue in the right-hand direction. So we're going to have x's greater than negative 1. And the only other question is, do we need an equal on that inequality symbol? And we do, because there's a filled-in circle at negative 1. So now that we have all of that, we can put our equation together. Our left-hand portion is 2x plus 3 if x is less than negative 1. And then our right hand is going to be negative 1x plus 3 if x is greater than or equal to negative 1.